continuing on with the questions now on page 67. So we've set up our table. Now we've got some questions that we want to answer about that table. So we're going to start by looking at question A here. So it says, if there are 1,008 students at Academia High School, calculate the total number of people who study or teach there. So this is talking about the total number of students at the school. Okay, so let's think about, well, what does that mean? We're talking about students. Well, we know at the school we've got both students and we've got staff, but we know that the students proportion, there's 87.2% of the people at the school are students, the rest of them are staff, so we know that 0.872 must be equal to the 1,308 that they've talked about. So we know that there are 1,308 students, and we also know that students make up 0.872 of all the people at the school. So if I take 0.872 and multiply that by the total number of people at the school, so the total number of people, then that should be equal to 1,308 students. Okay, so now what I want to do is I want to find out how many people there are in total. So I'm going to rearrange this formula. Opposite of multiplying is to divide. So I can say the total is equal to 1,308 divided by 0.872, and that's going to tell me there are 1,500 people at the school. So in total, question A, there's a total of 1,500 people at the school, including students and staff members. Okay, now part B. Part B is asking us how many male students attend the school. Okay, so we know that we've got, so we're talking about how many, so that's talking about the number. Okay, that's asking for a number, not a probability, a number. And this is how many male students attend the school. So we know we can find out what's the probability of being a male at the school. But we want to know male students, so we've got to be careful about that. So let's go back and look at our table. Here we go, male students. 45.6% of them, people at the school in total, are male students. And I want to find the number of male students, so I know that, so I've got my general formula, my expected value is my probability times n. In this case, the probability of being a male student is 0.456. So 0.456 times the number, which is a total of 1,500 people at the school, and that tells me there should be 684 male students from the 1,500 people there are at the school. 684 of them are male students. Okay, question C now. So question C is looking for what percentage of the staff is male. So this is a conditional probability, because it's not saying what percentage of all students, it's saying what percentage of the staff. So we're only interested in looking at the staff members. Okay, so we're just interested in the staff. So from the staff, what's the percentage that are male? So we know we've got 12.8% of staff members in total, and from that 12%, 0.07 are male. So we want the conditional probability of male given that they are a staff member. And that is going to be our 0.07 divided by the total number of staff, total proportion of staff, 0.128. So we're not taking it out of the whole school, we're just taking it out of the staff members. And they want that as a percentage, so let's multiply by 100, and that's going to give us 54.7% to 1 dp. So there is question C. Now on to question D. So let's look. Calculate the proportion of females that are students. So it's looking at the proportion of females, not the proportion of students or not the proportion of people at the school, but the proportion of females. So this is a conditional probability. We're saying the proportion of females. So I am only interested in the females. So now I'm just going to look at the females at the school. So I'm just interested in the females in the school. And I know that 47.4% of them, of the people at the school, are females, and the proportion that are students, here we go, 0.416 that's the proportion of people in the school that are female. So our conditional probability that we want to do, this is part D, we're going to say the probability of being a student given that you are female is 0.416 over the total proportion of females of 0.474. And that is going to give us, as a decimal, 0.878 to 3dp. Okay. Now let's have a look at the last one. Calculate the probability that a randomly chosen student is female. Okay, so it's talking about randomly chosen student. So we're only interested in looking at the students, and we want to know from all of the students what's the chance of being female. So it's another conditional probability. So we're looking at from the students. So I'm just interested in the students. So from all of the students, students make up 87.2% of all the people at the school. And we want to know that a randomly chosen student is female. So there is, the females is 0.416. So now I'm going to write down my probability, my conditional probability for this. So part E, the probability that a randomly chosen student is female. So the probability of being female given that they are a student. I know they're a student, that's the piece I know, and I want to know the chance of being female. And the chance of being female is 0.416 over the chance of being a student is 0.872. So it's 0.416 over 0.872. Turn that into a decimal, and that gives you 0.477 to 3dp. So that's telling us the probability of somebody being female, given that they're a student, is 47.7% or 0.477.